So I guess we are live. Hi everyone, very good evening and welcome back to GFG practice. Please let me know if in the chat if my voice is clearly audible to all of you. Then we'll start with the discussion of the weekly coding contest for this week. Uh, okay, and I'll check myself as well if I'm clearly audible. Okay, so yeah, I think it is working fine. So yeah, like you can react a thumbs up in the chat if everything is working fine, and then I would be sharing my screen and discussing the problems. Okay, so before I start, I want everyone to tell me that how many questions you were able to solve in this contest. Okay, so yeah, definitely let me know how many questions you were able to solve in today's contest. Okay, and then we'll move forward. So please comment something in the chat so that I can understand that everything is working fine for you as well. Okay. Right. One question Tej says, okay, what about others? Others can also quickly comment and then we'll proceed further. Okay. So, yeah, let's share the screen and let's start with the discussion of the entire contest. People are saying one question. Okay. Fine. No worries. I'll still be doing the discussion for every problem. So, if you were not able to complete it, no worries. So, yeah. Let's try and move forward and discuss the contest problems. Okay, so yeah, like today we are going to discuss the GFG weekly contest 169. uh, okay, and now let's discuss the first problem. There were four problems. The first problem was based on the string concept. Okay, it was quite easy also. Then second problem was basically regarding minimize cost, so it was a implementation plus sorting based problem. Okay, then the third problem was basically jumping game. Now this particular problem, jumping game, it was based on Dijkstra's algorithm. Okay, so we had to apply Dijkstra algorithm in order to solve this particular problem. Then after that, the next problem, the last problem that we had, if you will see the statement itself, update query and subtree product query. So when somebody says query, then and you are asking about updates as well, okay, and product query as well. So definitely the segment tree data structure comes to our mind, or similar data structures come to our mind. Okay, so for the last problem, you can use segment tree, or if you want, you can use similar data structures which are having functionality of segment tree here. Okay, so these were the four problems that we had. So let's quickly discuss the very first problem that we have for today, that is good strings. So let me start with this discussion. Okay, so how many you were able to solve? Everyone can tell me. Okay, so the very first problem that I'm going to do is basically good substrings. uh, Okay. Now, when you come to this problem, the problem says that you are given a string S which consists of the digits from 0 to 9. Okay. So basically, you can say string consists of digits from 0 to 9. Okay. String does what? String consists of digits. Okay. From 0 to 9. Okay, so the digits are there from 0 to 9. It is having length n. Then after that, what do we have? Like the problem says that a substring is defined as a contiguous segment. So substring is what? Substring is basically a contiguous segment of the string, and our task is to count the total number of substrings such that the conditions are getting satisfied. What conditions? The substring must be valid decimal number. So substring must not contain any starting zero. Okay, the substring that we are planning to consider, it should not consist of any starting zeros. Okay, and the decimal number that we are going to make should be odd. For example, if you'll consider the case where we have got like 1, then we have got 2, then we have got 3, then we have got 4. Okay, so if you consider this given string overall, then in this string I can say that if I take this string alone, this substring alone, that is 1 only, and I take this substring alone, that is 3 only, because whatever decimal numbers I'm going to make, they should not have any leading zeros, and at the same time the other condition that should meet is that they should be odd numbers. So if you see, if I just take 1, okay, then my purpose will be fulfilled. If I just take 3, my purpose will be fulfilled. If I take 1 3 also, right, then my purpose is fulfilled, because if I take 1 alone, that is an odd number. If I take 3 alone, that is an odd number. If I take what? If I take 23, that is an odd number. If I take 1 to 3 also, that is an odd number. So total answer is basically 4 here. Okay, so there are 4 such substrings that you can make. Now how can we solve this particular problem? So basically, whenever you are at a particular character, you have to get the corresponding digits. Okay, because if you will see, if you have got 1 2 3 4 here. Okay, suppose you are at this particular character, ith character is 3. Okay, so character 3 is there. In order to get the digit, what you need to do is you need to subtract 0 from it. Okay, whatever character you have, suppose you have character 0, if you subtract character 0 with character 0, you'll get what? You'll get 0 here. Okay, then after that, if you do what? If you subtract character 1 with character 0, you'll get what? You'll get 1. Then after that, if you subtract character 2 with character 0, you'll get what? You'll get 2 here. So this is how you can get the exact digits. Okay, character 0 with 0 will be 0, integer 0. 1 character subtracted with 0 will be 1. So that's how you can get the digit. Now once you get the digit, how do we make the decision? How do we make this decision that how many substrings will we have? Okay, so like suppose that if you have got what? If you have got 1 2 3 4 here. Okay, this is the string that you have got. Now you can declare an answer variable here, and we can have an I index, let's say 0. This is index 1, index 2, index 3. Okay, uh, now if you have got what? If you have got these I indexes here, right? Now after this, like if you'll observe here, so like basically what will be the length till that point? How many what will be the string length till that point? This, if I am considering this particular index, so how many characters are there from 0th till the third index? Total number of characters are basically 4 now. So whatever, if I want to get the number of characters till that index, that is basically I plus 1. Total number of total length of the substring will be I plus 1 till that point. Okay, if I consider from the starting. Now like what I will do is I'll always maintain a counter, that how many zeros I am getting. Okay, whenever I get a 0, okay, understand this thing very carefully. Whenever I am going to get a 0 now, in that case my answer is not going to get updated, because if you get the character 0, then you are having a starting 0. If you are having a starting 0, right, so in that case that substring should not be considered. So basically, if you will see, let's say I have my count. Initially, my count is 0. Now, when I come across this guy, so it is fine, right? So inside our answer, when we'll try to add, okay, so whenever the digits are odd, then we'll update our answer. So if you will see, so right now this digit is 1, so our answer will be I plus 1 minus with the count, whatever is the count of 0. So every time you can see count of 0 will be 0 only, because I will not have any zeros here. Okay, so what will happen here is, if you see, so initially this will be 1 minus 0, that is 1 itself. Okay, so you'll get one substring. And after that, next time what happens when you reach this particular index, that is here. Now after this, what will happen when you reach this particular index 2, where you have the character 3? It is odd. Now when you have this odd character, so you will be considering from here to here. Now how many substrings you will have? Like I plus 1 number of substrings is what you'll have, because I value is 2. So 2 plus 1 will be 3. So you have 3 substrings minus 0. So what 3 substrings you have? You have got you can basically say that you have got what? You have got 1 2 3, then you have got 2 3, and you have got 3. Okay, these are the 3 substrings that you have. And how many zeros you have got so far? You have got no 0. So that is why you will have 3 substrings more added. So 1 plus 3 will be total 4. So that is how we are getting our answer. So what you basically do here is, like, you keep a track of the number of zeros. If you have a 0 here, no, right, if you get a digit 0, then you increase the count of zeros. Okay, and if you get a digit 1, if you get an odd digit, basically digit and 1 means if you get an odd digit. The moment you get an odd digit, then from the starting till that point, you count the number of substrings. Okay, that will be I plus 1. The number of substrings from starting till that point will be I plus 1, because if you see, if I stop here, so I had the substring 1 to 3, then 2 3 and 3, so total 3 substrings. Okay, so I plus 1 number of substrings is what I have. I value is 2 here. Okay, so I plus 1 number of substrings minus whatever substrings, like minus whatever number of zeros I'm having, because whatever zeros I'm having, those substrings I don't have to consider. Okay, so this is how my answer will get built. So I plus 1 minus the count every time, I'll keep on doing, and at the end I'll return this answer. So is this code clear to everyone, guys? You can tell me yes or no, guys. Is the approach for this question clear? Right, what I need to do is, I need to check what is the digit that I have. Then after that, I need to constantly keep a track of the number of zeros. If the digit is a 0, count it. Okay, then otherwise, if the digit is 1, then total number of substrings that you can make till that ith index is I plus 1 number of substrings. But from those substrings, you will subtract the substrings which will be having starting zeros, because the substrings which have starting zeros, they will not be valid. Okay, if this is clear, you can write yes in the chat, and then we can proceed further, guys. Is this particular case clear to everyone? Very easy and straightforward question. Okay, can I say that everyone is clear? If yes, then you can react to thumbs up, and we can proceed further with the next problem. Okay, so time complexity for this will be order of n, and space complexity would be order of 1, because I'm not using any extra space. Very good. Now let's move on to the next question for today. That was minimize cost. So let me write this here. Okay, the next question was basically minimize cost. Okay, now when it comes to this question, that is minimize cost, what do we have here? So when it comes to this question, that is minimize cost, we can also remove zeros from string and then do this. Like, but in that case, you will be using extra space, not Tej. So I don't want to use any extra spaces, right? That's the main thing. Now let's come to this question, and you can react to thumbs up, guys, right? Since a lot of you are watching. So yeah, minimizing the cost. You are given two integer arrays A and B. So you're given what? You're given two integer arrays A and B. Okay, fine. So like you have an array A, fine with that. Now you have another array B. Okay, what do we have next? Like we have each array has the length n. So n is the length of both the arrays, right? So both the arrays have got n length. This is also fine. Now what else do we have? Like it says that you have to make two arrays identical. What you want to do is you want to make both the arrays identical. Okay, A should be a permutation of B. So we want to do what? We want to make both the arrays identical. Okay, we want to make both the arrays identical. Okay, I'll check your comment, don't worry. Now, if you want to make both the arrays identical, right? So by performing swaps, so you can swap the elements. Now, how can you swap that? There's a condition given for swapping. Okay, the condition is that if you are swapping the AI element with the BJ element. Okay, so basically what you can do is you can choose an element I from the array A. You can choose an element AI from the first array. Okay, I guess that is what they have written. And you can choose another element BJ from the second array. That is what you can do. Once you have done this, right? So you can choose AI element from the first array, BJ element from the second array, right? And then you will swap them. Okay, so swap AI and BJ with the cost as the minimum. Okay, so if you're going to swap these two elements, okay, suppose you are going to swap the element AI of the first array with the element BJ of the second array, then what is the cost that you have to pay? The cost that you have to pay for this will be the minimum of the two elements. Okay, whichever element is the minimum of the two, that is the cost that you will end up paying. So minimum of AI comma BJ. Okay, this is the cost that you're going to pay here. Okay, now what you have to do is your task is to minimize the cost of all the swaps so that you can make both the arrays identical. If making both the arrays as identical, if that is not possible, in that case what you need to do is you need to return basically -1. Okay, so you have got this array, right? So let's say if you have got the array as what, like let's say you have got the array as, and you can choose any element, I guess. You can choose an index I and index j, and you can swap here. So now if you see this, so you have got 1, then you have got 2, then you have got 2, and then you have got 2 here. Okay, this is the A array that you have. Now what is the B array that you have here? You have got 1, then you have got what? 2, then you have got what? 4, and then you have got what? 4. Okay, so this is the second array that you have got, right? So can I do a swapping and make the same? Yes, basically if you see here, if I swap these two elements now, okay, then I'll be able to do my job. So if I swap these two, then like 4 will come here and 2 will come here, and the cost that I'll have to bear is 2 only, the minimum of the two elements, and I don't have to make any other swap, so my answer will get done. Okay, so yeah, this is what will happen. Now for the second test case, you can see that it is not possible. Why? Because the first array has got the element 2 and 4, the second array has got the element 2 and 3. So definitely it's not possible, because both the arrays do not have elements in such a fashion so that you will swap and you'll end up getting the identical arrays, right? So you'll return -1 here. Now let's see what I have done. So basically, first of all, in terms of logic, what I've done is I have I have got a set here. Okay, now what will the set do? Like inside the set, I'll be storing the elements of both the arrays. Okay, set does what? Set data structure will help me to store the unique elements, right? It will help it to store all the unique elements, right? So that is why what I'll do is, first of all, I'll iterate in the array and I'll put all the elements. So if you had this particular test case, suppose you had this particular test case. So what will happen in my set if I have the set data structure here now? So first of all, 1 will come, then 2 will come, and then 4 will come. I guess this is what will happen with my set, because if I'll insert all the elements of the first and the second array, then only the unique elements would be remaining here, correct? Then after that, I also need a map, because I need to maintain the frequency of both the elements. Okay, so I need to have a frequency a, right? First array, for every element I need to have the frequency. So frequency of 1 is 1, then frequency of 2 is what? The frequency of 2 is 3. Okay, then the frequency of this is what we have. Then after that, talking about the second array, so frequency of 1 is what? 1 is 1. Frequency of 2 is what? 1. Then frequency of 3 is what? Sorry, frequency of 4 is what? 3. So I will update the frequencies of all the elements also, because when it comes to balancing here, no? So when it comes to making the array same, definitely you need to consider the frequency of the elements as well. Then after that, what you need to do is, you need to check how many operations would be required here. Okay, so we will have we'll keep an operation array. Okay, the operation array will be what? The operation array will basically be storing inside the operation array, will be storing what? Will be storing the operations that would be required. Okay, like basically whenever we are doing an operation now, whenever we are going to do an operation, so whatever element we are using, we'll put that element inside the operation array. Now after that, we'll iterate in the element array. So let's say you'll iterate here. Okay, so suppose that you will iterate in the set one by one. Okay, so we have got the set, so we'll iterate in the set one by one. Okay, so if you iterate and if you come across 1, when you come across the element 1, you will see that what is the frequency of 1 in the first and the second array. So if you see the frequency of 1 in the first array, so 1 is present one time in the first array and 1 is present one time in the second array. So it is present equal number of times. If it is present equal number of times, then I don't have any issues. Okay, so and when will I return -1? If any element is present unequal number of times. Okay, suppose if elements are, suppose that in the first array a particular element is present 5 times, in the second array element is present 4 times, same element is present 4 times, then one element is extra. Now if I have odd number of extra elements, then I cannot handle this situation. Okay, because if the first element suppose has got 9 elements, second array has got how many elements? 6 elements, so the difference will be 3. Okay, if I'm talking about a particular same element, if I'm talking about element, let's say 10 is present 9 times in the first array and it is present 6 times in the second array. So 3 elements, 3 is the difference. Okay, 3 occurrences are extra. So if 3 occurrences are extra, so it is odd. So I will not be able to balance. So if any element is present odd number of times, I won't be able to balance that. So I will return -1 in that case. Is that clear to everyone? Please write yes or no in the chat. Okay, if any element is present odd number of times, I will not be able to balance the situation. So in that case, I'll be returning -1. Otherwise, if I'm able to balance, right? So in this case, if you'll see, so obviously both are present how many times? X is present one time, y is present one time. So if both are present one time, so when I'll take the difference, so it will be come out 0. So I don't need to insert this. Then when I look for the next element 2, so 2 is present how many times? If you'll see, so the element 2, the difference will come out to be how much? 2 is present 3 times in the first array, one time in the second array, so difference is basically 2. So 2 extra occurrences of 2 are there. Okay, basically if two extra occurrences are there, so I need to give 1. So that is why I'm iterating difference by 2. Okay, whatever is the difference here, half of that I need to give to the other array. Okay, half of that I need to give to the other array. That is why I'll put that element inside the operation array, indicating that many times I need that particular element. Okay, for example, if 2 was present, if the difference comes out to be 2, for 2 is present 2 times extra. Okay, so I need one. I need to say that whatever is the difference by 2, that many times, that is one time. I need to swap 2. So in my answer, I'll do what? In my operation array, I'll say that I need the swapping of 2. So that's why in the operation array, I'll put what? I'll put 2 inside. Okay. Then after that, if you'll see 4 also, right? When you look at 4, so 4 is present how many times? 4 is present in the first array 2 times. Okay, when I come across 4, 4 is present in the second array 2 times. In the first array, it is present 0 times. So the difference comes out to be 2. If the difference comes out to be 2, so half of the occurrence I need to supply to the other array. So one occurrence I need to supply to the other array. So in the operation array, I'll put 4. Okay, now you can see that the elements that I want to swap is what? I need to swap 2 and 4, 1, 2 and 1, 4. Okay, so uh, if I had a lot of elements also, then only I need to consider the first half, right? Like basically, if I'll sort the array in the ascending order, then I will take only the first half after sorting. So only I'll take this element. Okay, so this means that if I'll take this element, then I am swapping 2 and 4 in the first and the second array. Okay, so this is what we are doing. If this is what you are doing, guys, right, so the cost will come out to be what? 2. If suppose that the operation array look like what, if the operation array was, let's say, 1, 3, then 5 and 7, suppose that these are the elements that you needed to swap. So you will not swap, you will not pay the cost for 7 and 5, you will pay the cost for the lesser elements now. So you'll pay the cost for 1 and 3 here. That is what you will do. Okay, so that's why the cost will come out to be less. So you can see here that if the elements are present, if there's a difference in the occurrences, right, so half of the elements need to be supplied to the other array. Okay, so half of the elements need to be supplied to the other array. So that's why in the operation array we'll put them. Then after that we'll do what, we'll swap, like we'll sort the array in the ascending order. Once we have done that, then we'll see that how many operations we need half of the operations. So we'll iterate in the array and we'll add these operations. If this is also clear, you can tell me, guys, in the chat. Right, does this make sense to everyone? For the test case that you are saying, I guess the optimal answer, 1599, you can check it using the custom input also, right? If you are telling me the array as what, you're telling me the array as 1, then 5, then 9, and then 9, and then after that you are telling me 1, then 5, and then 7 and 7. You can check the official answer here. Like if you'll check the expected output here, no? Let's check. So expected output would be what, let's check what happens. Expected output is -1, but I guess I might have made mistake, that's why. Right, so yeah, let's see this now. So optimal answer will be 7 here. No? For this particular test case, you can see expected output is 7. Obviously, it will be 7 because you will be swapping 6, 7 and 9. No? So it will be 7 only. No? Answer is 2. How answer is 2? How do you think that the answer is 2? Because actually you need to swap 7 and 9 only. No? So if you'll swap 7 and 9, so cost will be paid is 7 only. You cannot swap like, uh, because if you swap this one, then the arrays will become equal. Okay, so the cost will be 7. 7 is correct, I guess. We don't like, see, we don't have to take care of which element is coming from which array. Okay, elements can come from the arrays. Like the thing is that about the operations, right? So the minimum number of operations will be the lesser elements. The lesser elements will help you to consider minimum operations here. Okay, so I hope that this question is also clear. Is everyone clear with this? You can write yes in the chat, guys. Then we can think of proceeding further. It's a very straightforward question, nothing much difficult. You can write +1 if you're clear with this question, and you can react a thumbs up to the video also, guys, so that we can think of proceeding further here. Okay, is this question clear to everyone so far? You can tell me, then we can proceed further also. Okay, is this question clear to everyone? If yes, let me know, and then we can think of proceeding further. Okay, I'm looking at the charts. You can tell me if you still have any doubts. Yeah, I told you na, the answer expected is 7 also, so I guess we'll get 7 only. If you saw anywhere that the output was 2, you can tell me, but I also believe that the output will be 7 only, because one occurrence of 9 and one occurrence of 7 needs to be swapped, so minimum cost will be 7 only. Okay, so let's submit this. This will get accepted because I have already written the code here. Okay, can we proceed further in that case, guys? I guess we can. Right, so let's proceed further to the next problem here. Yeah, so if you feel that any test case is wrong, then what you can do is now you can report it. Okay, I guess you will get an option now somewhere, report an issue. So definitely you can report the issue if you feel that any test case was wrong. Okay, order, yeah, order does matter, that's fine, but you have to calculate your answer now, you have to calculate your cost, you don't have to print your order here. Okay, understand this thing. The next question is basically jumping game. Let's have a look at this particular question here. Okay, now let's see what the question says here. Okay, question says that like, were you able to solve the jumping game problem, or in fact the tree query problem? I don't know, but yeah, the prerequisite is that you should know the extra algorithm, and you should also be knowing uh, this particular segment tree data structure also. Okay, now in this jumping game problem, Geek is playing an adventurous game. Okay, in the arena with platforms. Now there are n platforms in the arena numbered from 1 to n. Okay, so platforms, n platforms are there. Fine with that, and they are numbered from where to where? They are basically numbered from 1 to n. Okay, then after this, like one base indexing is there basically. Then after this, they are saying that each platform has a jump pad that lets Geek jump to other platforms. Okay, so like, just in case if you want the code also, na, side by side, if you want to look at the code, so I'll just generate the code also for all of you, so that you can use it. Okay, just give me a second. I'll generate the code side by side so that you can use it as well along with me. Okay. Yeah, so for this problem I have shared the code here. Okay, yeah, now if you'll see here, it says that for every platform that is there, na, Geek has a jump pad, so that lets Geek jump to other platforms. From the ith platform he can jump forward or backward. Okay, it's like he can jump forward or he can jump backward. Okay, suppose that if Geek will jump forward, then what will happen? So if he is standing at a particular ith place, I guess, right, then what Geek can do is, Geek can jump, if he's standing at I, so he can jump I plus di forward, or he can jump I minus di backward. Okay, that is what they have mentioned here. Okay, di is the distance for every platform. So he, either you can jump this much forward from an index, or you can jump I minus di backward from that index, and di is given to you. Okay, for every platform. Now, but Geek has to stay within the arena. So Geek wants to stay inside. You can jump forward, backward, all that is fine, but you have to stay inside. Okay, he can't land outside the platform. So every cost will every jump will have some energy. So every jump, that the ith jump is going to have ci amount of energy. Understand this thing very carefully, that if the Geek takes the ith jump, okay, so if the Geek is taking what, if the Geek is taking ith jump, then in that case what will happen? In that case, Geek has to pay the cost ci. Okay, so your task is to find the minimum amount of energy that you need. Okay, so you have to tell the minimum amount of energy that you need, need to reach the platform n, like to reach platform n from each platform. Okay, so from like from each platform you have to answer cannot be 2, yeah. So yeah, like every jump cost energy, and the energy needed to jump from the platform is ci given to you. Now your task is to find the minimum amount of energy here, and that Geek must spend to reach the platform n from each platform. Okay, so you need to return an array with the minimum energy. So basically you need to update the minimum energy required at every place, right? And you need to return an array with the minimum energy required for each platform to reach the end from every platform, like whatever is the minimum energy required, so you have to tell that. Okay, if it is impossible to reach, then in that case, if it will still be infinity at the end, then you have to return -1. Now when somebody tells me, about this line now, that you need to return an array which with the minimum energy required for each platform to reach, so obviously I can see a couple of things. Okay, whenever I'm going from somewhere to somewhere, if I'm going from somewhere to somewhere else, I am paying a cost for it. So I have a weighted graph. Understand this thing very carefully. How do you observe that this question is basically Dijkstra based? So you can see that this is a weighted graph. Why it is a weighted graph? Because like okay, let me just remove this again. Yeah, why this is a weighted graph? Okay, this is basically a weighted graph. But why? Basically this is a weighted graph, guys. The reason for that is because like you have a cost from, if you're going from somewhere to somewhere, right? If you're going from I to I plus di, or you're going to I minus di, so there is a ci cost that you're paying. So like if you're going from somewhere to somewhere, from station A to B, right, assume that this is I and this is I plus di platform, right? So you're paying a certain ci cost for it. Okay, so this makes the graph, this is basically a graph, right? And every the graph has got edges, you can understand that. Now like edges which are having weights. Okay, now after that, like the question also says, so this is one thing, but the question also says one thing, that you need to return an array with the minimum energy required for each platform to reach the end. Now whenever somebody says that I have to find the minimum energy that is required to reach every platform, from every platform to reach the end point, so basically this is what, this is the extra algorithm, no? If you will solve using recursion, I guess recursion will help you to generate all possible ways, but according to the constraint, I guess you cannot, because the constraints are very high, no? So using recursion bundle might be very heavy, because if you will use recursion for such a problem, it might be very heavy here. Okay, so yeah, like that is why, like you can understand that you have to use Dijkstra algorithm, because you have to get the minimum cost for from every station till the end. Okay, now let's have a look at this code. Okay, so one thing is that the prerequisite for this problem is the implementation of Dijkstra algorithm. So definitely you should be knowing about the Dijkstra algorithm before you come across this problem. Okay, now what is the very first thing that I need? Do we, like, tell me, are we given, like we are like have has the adjacency list been given? No, adjacency list has not been given. Okay, we are not given any graphs directly, we have just been given the statement. So we need to build the adjacency list. Okay, build the adjacency list. Okay, and if you remember now, we need to build the adjacency list here. If you want to build the adjacency list now, hi Naikaj, like nice to meet you after a long time, right? uh, so yeah, you are on this channel since at least 2.5 years, I guess, right? So yeah, if you'll see here, right, we need to build the adjacency list. Now how does the adjacency list look like? If you have a and b, no, right, an edge, and the weight is w, so adjacency list will look like what? In the adjacency list of a, you will want what? You will want basically the node b, and then you will want what? You will want w here, that is the weight. Okay, then let's say from a you are having some connection with, let's say, e, and the weight is w2. So whatever is there, so you will have in the adjacency list of a, you will have e with the weight as w2 here, whatever you have here, right? So this is an update. This is how we need to update the adjacency list. With respect to every node, you need to have the connection, and then whatever is the cost for that edge. Okay, is that clear to everyone? Okay, so yeah, like what you will do is you'll have a like you need to have a for every node, you need to have store pairs here. Okay, this is a pair, no? This basically is a pair, so that is what you're having here. Now what you will do is like if you are at the ith index, right, so you can go I plus di and you can go I minus di. Now if you're going forward, you will not add those paths which are going outside. Okay, so if you will see here, like if you are at the ith position, right, so if you're going forward, like see, if you are at I, if you're going forward, so you're going I plus di, correct? If you're going forward, now if you're going this much forward, now it should be inside the range. If you're increasing, so this should be inside the range. If it is inside, then you can say what, that inside the adjacency list of I plus di, that is going forward, if it is inside, then inside this adjacency list, you will push which pair? You'll push that you have got I along with the weight as what? Ci, that is the cost that you will pay. Okay, and if you're going backwards, that this means what? Going backwards means I minus di. If you're going backwards, this indicates I minus di. Okay, so if you're going backwards, you should not go outside, so you should not go beyond zero, you should remain inside. So like you should not go beyond zero. So if you're going backwards, I minus di, it should be greater equal to zero. In that case, inside the adjacency list of I minus di, this is a destination. Like with respect to this, in the adjacency list, you will push what? You will push I comma ci, because from I you can go backwards now. So you will make the adjacency list like this. Okay, is this part clear? You can write yes in the chat. Okay, once my adjacency has been built, then what do I need? I need to run the Dijkstra algorithm. Okay, and I need to pass what? I need to pass the number of nodes that I have. So I need to pass n here, that is the number of nodes. Then I need to pass the adjacency list, that is the G graph that we have, and we need to pass n minus 1. N minus 1 is the destination. Okay, n minus like sorry, n minus 1 is basically your source node. Okay, because from this source you want to find the shortest distance for every other, shortest cost, you want to find the smallest cost from this particular source node, that is n minus 1, to every other cell. Okay, that is why we are passing this. If this part is clear, please write +1 in the chat, guys. Is this much part clear? Very simple and straightforward question so far. If you're clear, you can let me know. If not, you can tell me which part is not clear. But I hope that you're clear so far. If you're clear so far, you can give me a +1 in the chat as well, guys. Does this make sense to everyone? If yes, please react a thumbs up to this. Okay, then you'll run the Dijkstra algorithm. I'm assuming that you already know Dijkstra algorithm, because if you don't, then you'll be not able to solve this problem. So see, initially we update all the distances as infinity. Okay, the prerequisite is that you should be knowing Dijkstra algorithm. I cannot help with Dijkstra algorithm explanation, because that itself is a topic, right? So you can search GFG practice Dijkstra algorithm, or you can read about it on GFG, right? If you don't have knowledge about this, so that next time you'll be able to solve such a problem. Okay, so you'll initially update the distance as 0. Then in the priority queue, what we are doing is we are updating the, like, priority queue is a min heap. Okay, so the minimum distances will be at the top. Then inside the priority queue, we are pushing the weight with the source here. Then after that, if the priority queue is not empty, we'll iterate, and then we'll get the node and we'll get the distance. Okay, the top second will store the node and the top first will store the distance. Then we'll pop this pair out. If the distance is greater than the, like, if the distance that I am having, if it is greater than the distance uh, then the cost required to reach this particular cell, all right, then I'll continue, because I have to skip this, right? If I'm paying more cost than what I have already paid, if I already have optimally calculated the cost for reaching the current node now, then I'll directly move away from it. Otherwise, I'll iterate through the adjacency list of the current, this particular node that I have, and v is the node and w is the weight. Now if I have a shorter path in order to reach my connection, if I have a shorter path, if I have a basically lesser cost path, then I'll update that lesser cost path. Okay, if the distance to reach till the current node plus this w, if it is lesser to reach this particular v node from the source node, that is n-1 end node, then I'll update the distance and I'll push it in the priority queue. At the end I'll return the distance array. Now once I've returned this distance array, if the distance for certain stations are still what if the distance for certain stations are still infinity, this means you cannot reach them, so you have to update them as -1, indicating that you cannot reach them, and you have to return the answer at the end. If this is clear, you can write yes in the chat. Okay, does this make sense to everyone? You can write yes in the chat if this part is clear. Okay, it's basically the extra algorithm, nothing else, right? So you have to build your graph and then you have to do the job. Okay, is everyone clear with this? I hope you are. I have shared the link already. Just in case if you want, I'll try to share the link once again. Yeah, basically relaxation. Okay, can we move on to the next? So basically third problem was based on build the graph and run the extra. It was quite easy, I guess. Maybe it was easier than the second one also, because it was very straightforward. Third problem was very straightforward. Build the graph and run the Dijkstra algorithm. Okay, can we move forward now? I guess we can. So let's move forward now, guys, to the last problem that we had. It was related to tree queries now. Okay, so let's have a look at this particular problem. Tree queries. Okay, like you are given you are given a tree which is rooted at 0. Okay, each node of the tree is associated with an integer value, so every node of the tree has got an integer value represented by an array. So array is given to you, right? The tree is provided by a 2D array G of n-1 size. And what does the 2D array have? Like we'll see to that. Okay, so G represents an edge between the two nodes. Okay, so the G that is there, it is representing basically an edge between the two nodes. Now you have to handle the queries here to provided in the 2D array. So the 2D array, the G 2D array that you have, it basically has got queries here. Each query can be of following type. Each query is of two type. Now what are the types of the query? You have an update query and you have like basically you have got an update query. Whenever you have got update query, you need to find a data structure which can efficiently update. So update query is what? Update query is like 1 x comma y, 1 comma x comma y. Now update query is what? That like you have to change the value of the node. So whenever you have to change very fast, you have to use segment trees here. So you have to change the value of node x to y. Okay, so you have to change the node value x to y, means that you have to update the ax value to y. So change the value of the node x to y. Okay, change the value of node x to y. Okay, that is what you have to do. Now another thing that you have to do is like you have to find the product. Okay, when you have to find the product, so you have been given this thing. You have been given 2 comma what, like x comma minus 1 here. Okay, now what does this mean? You have to calculate the product of values of all the nodes in the subtree rooted at x. Okay, so all, like if there's a subtree, like let's suppose that this whole is a tree here. Okay, now if this whole is a tree here, so you have got, let's say this is x, so you have to calculate the product of all the elements here, I guess, right? That is what you have to do. Right, and you have to take the modulo of it also. So calculate the product of all the nodes in the subtree rooted at x. Okay, so starting from x, whatever is the subtree, you have to calculate the product of that. Okay, then your task is to return what? Your task is to return an answer array of length what? Length q. For the ith query, you have to return this thing. Okay, if the query is of type 1, then you have to then the ith element is -1. So if the query is update, then you have to put -1 in the answer, because if you're updating them, then you're not getting any answer, so you have to update -1. But if the query is of type 2, if you are doing what, if you are basically finding the product, so whatever is the product, you have to take the modulo with 10 to the power 9 plus 7, and you have to return it. So like basically you'll be applying segment tree here, because you have to update the ranges very quickly. Okay, and they are asking for for product as well. Okay, so let's have a look at this particular question here, like what all we need to do and what all will be given to us as well. Okay, so basically firstly you can say that we need to have what, like we need to build a segment tree. So let's talk about the segment tree function. Can you provide this code of this question? Yes, I can provide you the code also if you want. Just give me a second. I hope this is getting accepted. Let me just check this and then I'll provide it. Okay. Okay, so I have given the code for this particular problem as well to all of you, right? Yeah, so let's have a look at this code here. Like mostly functions related in this code are related to segment tree. Okay, so we'll have a segment tree vector here. Okay, segment tree vector will be doing what? Like basically segment tree is stored in form of an array. No? So if you don't know about segment tree, you should learn it. You can learn it from GFG and code forces like websites. Okay, we have the modulo also. Right, then we have LNR. Now what we have is like firstly we have the adjacency list also, because we have to like make sure that we are using it. Now like whenever you're multiplying, so like a into b, so you will multiply it in long format and take the modulo here. Now talking about the update query, so like segment tree is very straightforward. I'm not going to explain the segment tree because that will take 1 hour itself. If I'm going to explain segment tree and how it works, right? I'm assuming that you are solving this problem, so you already have idea about segment tree. If not, then you can read about it from GFG. Okay, so if you're like, see what happens is if you are doing a query, so let's first see the code from scratch here. Okay, so yes, you're going to do the queries here. Okay, now if you see, you have been given the edges. Okay, see, you have been given the edges here. Now if you have been given the edges, it's your responsibility that you need to build the adjacency list. You need to build the adjacency list first of all from the given edges, right? So like we have this L array. Initially it is initialized to the size as n. R array is initialized to the size as n. Okay, then we have the adjacency list. I'll tell you about everything, why L is used, why R is used, and all. Then we have the adjacency list. So whatever edge list has been given to us, we need to insert inside the adjacency list of A, we need to insert B. Then inside list of B, we need to insert A. Then we start our DFS from zero. Okay, so what we need to do is we need to run our DFS starting from zero. Now what does this DFS do? So like when we'll be starting with this particular DFS here now, so we'll be updating the L and the R array and the visited. Okay, so like if you'll see this particular question here, right, so yeah, so like for every node there is an integer associated with it. Okay, that is the value for it, and the tree is provided like this. Okay, we have to handle the queries here. So like what we will do here is by running this DFS call, okay, over here. Firstly, like we have the stack. Okay, so inside we have the stack here. We are starting from the root node, that is the starting node. Okay, and we'll be running a DFS. We have the visited array. Now what we'll do is we'll iterate until the stack is not empty. We'll take out the element and we'll take out the other part of the pair as well, if suppose that the node is not visited. Okay, then in that case we'll push the node along with the p value. Now we'll mark it as visited, and L is the time that I came to that node. Okay, you can say that L is the time if that node was not visited. So L is basically the time that I'll come to that node for the first time. Okay, so I'll update that in the L array. Then after that I'll iterate through the adjacency list, and it's like I'm running a DFS. Okay, so I'm running a DFS using a stack. So if the node is not visited, I'll keep on putting that inside the stack along with the along with the parent. Okay, so like I'm inserting the node along with its parent here. So basically I'm running a DFS. I'm running a iterative DFS here, but if you want you can also run recursive DFS. Okay, so that is very much acceptable here. So basically whenever I'm going to visit a node for the very first time, I'm updating that time. Okay, and then R is the time that I uh, like that I'm updating at the end last. Okay, if this node is already visited, then I'm updating R here. Like R is the time that when I'm kind of going back. Okay, so like if I've already visited it, then I'm updating that time in R. But if I come to the node for the first time, then I'm updating L here. And if I update for that particular node, then for the node U that I'm currently at, then I'm iterating through all the connections of that node. Okay, and I'm pushing them inside the stack. So this is what we are doing. Basically you are updating the in time and the time at the R is the rightmost time. Okay, so L is the time that you come to the node for the first time. Okay, this is what you have. Now after that, like what you have is like you'll have a segment tree. Why we declare a segment tree of 4 cross n size? So you can read about the theory of segment trees. What happens is we have to always declare a segment tree of 4 cross n size, because we always want to make it a perfect binary tree. So if there are n nodes, n leaf nodes that we have, so we'll have to declare a segment tree of 4 cross n size, so that it is a complete balanced binary tree. It is a completely balanced, so that we can always return the queries very efficiently. So we have to maintain a segment tree of 2 cross n size. Okay, like 2 cross time basically. Okay, now after that, and if you have not solved this time based approach, then you'll not be able to understand this also, right? So yeah, if you'll see here, you'll call the update array, you'll pass li and ai here. Like once you're calling the update, so with respect to the in, you'll update the ai. Okay, so the time at which you came to this guy for the first time, you're updating this ai node here. Okay, then after that, when you're running the query, so let's talk about the update function in this. So when you'll call the update function, so you will start from 0 comma 0, you'll pass the n minus 1. You'll start from the 0th index of the segment tree, you'll pass the starting and the ending range, you'll pass the index I, and you'll pass the value that you want to update here. Okay, so you can see here that when you're calling the update now, so basically you are passing what you're passing the index time. Li is the starting time, that will behave as the index for me, and ai is the ending time. Okay, so that will behave as the value for me. Okay, because ai was the value here. Right, now when you're calling the update, so if you reach the last node, that is low is equal to high, if you reach the last node, then in that case you'll update the segment tree with that particular value, and you return. Otherwise you have to break the problem. So otherwise you have to find the midpoint, and if you're in the first half, then the left child index is the index of the left child is 2 into index plus 1, and the right child index is what, 2 into index plus 2. Okay, so for the left you will call for low comma mid, for the right you will call for mid plus 1 till high. Okay, then after that is done, right? So since you like after that particular part is done, then you need to update after you have updated for the left and the right, then you need to update for the node. Okay, so once, like, see, once you will go down and you have updated for that particular node. Okay, suppose you updated for this node. Now when you're going back up, so it's your responsibility that you update the above node before going, you update the parent node. Okay, similarly when you will go back up, right? So suppose from here you go back up like this and like this. Okay, so then this particular node is there, so you'll update based on this data, and this data you'll update the product here. Okay, that is what we are doing here, right, in terms of update. Now when it comes to the query part, right, so whenever we are running the query, so we are going to check whatever query we have. If we have one, then if we have one, then we have to do the update. So we are doing the update, and inside the answer array, inside the answer array we are pushing -1. But if we have to do the product query, then we have to take the product from where to where, from if you have to take the product, right, so you have to take the product from lu till ru, because if you will see here, if you will see the product query now, so for that particular node x, right, for that particular node x, whatever is there in the subtree, so the time array has helped us to build the subtree. So based on that, whatever nodes are lying inside that range, okay, because we have updated according to the time array, so whatever nodes are lying in that time period, okay, those nodes will lie under my subtree. Okay, okay, because I'll do the query in those nodes. So I'll find the product of them. How do we find the product? So basically query is also very simple, right? If you are going outside the range, then you'll return one. If you are completely inside the range, then you'll return directly that node. But otherwise you'll find the mid, then you'll get the left, you'll get the right. Okay, once you get the left and the right, you have to multiply the left product with the right product. Okay, so we have already we have written the multiplication function for that. Okay, so this is how we can solve this particular problem. I hope you have understood. So basically, with respect to the node X, using the L and the R array concept, that is the time that you come at the node for the first time and the last time. During that duration, you will get the idea of all the nodes that are lying in the range. Okay, so you can take their products. Okay, they will be in your subtree. So you'll take the product from LU till RU, and these are the indexes basically, right? So in the segment tree. So you need to take the product for product starting from LU index till RU index, and you will return that. So if this part is clear to everyone, you can let me know in the chat, guys. I hope that you're clear with this, right? You can write yes in the chat. And obviously segment tree is a topic that you need to learn before solving this problem. And since this problem didn't give you a tree straightforward right away, so you needed to run a DFS so that you can update the L array and the R array, so that you know the in time out time, such that you know that for a particular node X, what nodes are there in the subtree of it. So L and R array will help you to understand that. Okay, and if I pass with respect to the node U, if I want to find this product of all the nodes that are in the subtree of it, so I need to pass LU RU, that will give me the product here. Okay, so I hope you have understood this clearly. If yes, you can write clear in the chat, guys, and that's how we can uh, proceed further. Okay, so I hope you have understood everything clearly, guys. Please do mention if you have clearly understood or not. Okay, I hope that everyone is clear. Right, I have shared the code in the chart as well. You can try it out. Okay, dry run would be very big, so I'm not doing it, but try to understand this concept. And yeah, next time if this concept comes up again in any contest, you should be able to solve it. Okay. So yeah, guys, I hope that you have understood this problem also clearly. First problem was strings. Second problem was greedy kind of a problem. Third was Dijkstra algorithm along with graphs, adjacency list building. This one was tree based problem, where you have to apply segment tree for calculating the queries very fast. So I hope you have understood all the things clearly. Okay, just in case if you have any doubts, you can ask in the comments, and I'll clarify that up. If you have any doubts regarding the L array, R array, you can ask that also. I'll clarify that up also. And we have written this void DFS function. It's a iterative DFS. So I hope you have understood this as well. Okay, with that being said, that's it for today, guys. Thanks a lot for joining in for this particular session, and I'll see you all in the next session. Till then, bye bye, guys, and take care. All the very best. Thank you for joining this session at Geeks for Geeks, and keep coding, guys, and keep solving the weekly contest every Sunday. Thank you, guys. Take care. Bye.